In this video, I'll walk you through the Houdini scene file and break down the process I used to create the gestation effect. In the beginning, I tried couple methods, do animation with Vex in Soap Solver as well particle simulations, but best way to achieve organic look is to use Vellum Solver and Voronoi Fracture. Let's check the setup. I started with a sphere, created Vellum configure balloon node to set constraints and output pressure group. It's allowed later to control rest length value from dot network with Vellum constraint properties node. I won't go into details of this part of the setup because I followed Team Van Helsdiken tutorial about cell splitting with Vellum Solver, and if you're interested you can go and check original video, it's a very nice guide. I did couple adjustments though. I use groups and split nodes to separate preserved cells from dividing one, it gives more stable result. Another thing, I added cell ID primitive attribute to be able later do basic copy operations and use it for seed calculation and so on. After importing from dope to SOP level, we can check velocity attribute. Later I will use it as initial velocity for smoke simulations to maintain the directionality of cell motion due to division process. Scale it down a bit. After that, clean up attributes, keep velocity and some primitive attribute. Here you can see end cell ID. Let me visualize it. Let's create color node. Set random from attribute and choose cell ID, class primitive. Let me dive into loop network to find first layer of effect. Alright, inner cell part. Here I added boolean node with union operation to not have overlapping in case of an intersection, calculating normals, and applying transform to get better look from camera view. Later I will reference this node for all other parts of the setup. Next layer is connection lines between core and outer shell, but I'll talk about it later. Now let's check core part itself. This object merge fetching cell central points, I generated them in the for each loop, using cell ID to separate every cell independently. After that, extracting centroid and copying cell ID to generated center point. Inside SOP Solver I created life attribute, basically it's one frame incremental. Setting p-scale and parent ID, copying spheres to points, and transferring velocity attribute generated in point velocity node with central different approximation. Creating class attribute, and inside for each loop adding noise to points position. I am using AA flow noise, absolute value to avoid negative numbers, fit range, clamp values, and fit to displacement. To get animation, I fit time to flow parameter and control speed with multiply by constant node. Recalculating velocities, converting it to VDB and adding pyro source node to scatter points with density attribute inside SDF. Increase the load density value, transferring velocities, and normalizing it. Next, volume rasterize from attributes for density and velocity, and finally pyro solver. Nothing special here, in fact I do not use temperature so I can disable it from sourcing as well as flame field. I have pretty high dissipation because I do not need smoke stay too long. In shaped up I'm using disturbance and turbulence with density as control field and small amount of viscosity. Exporting density and velocity fields, converting them into VDB and using 16-bit float, as well resampling velocity field. Caching it. Let's display cell itself. So now you can see core smoke stays inside of the cell. Here I am splitting density and velocity fields. Density I will render as smoke inside core geometry. Here I clamp density value, I want to keep only high density area. And referencing final orientation of effect. In this part I am doing core geometry, again clipping low density values, scattering points inside, and running particle simulation. Inside PopNet I advecting particles by volume. Speaking about particles advection topic in Introduction to Houdini Particles course, you can check it on my channel. Reading velocities from pyro simulation, using PopKill to delete zero speed particles, recalculating velocities by ID, and doing particles trail with 7 substeps and frame duration 2. Using scale along length option, using width attribute as pscale, and creating VDB from particles. Now let's take a look at second branch. Again, prune low density area, convert into SDF, resample it, but I think resample VDB node is some legacy node thing, so you can skip it. Creating points from volume and using density as pscale attribute. Modifying pscale values, converting it to SDF volume, and smoothing VDB. After caching, I created single volume with SDF union operation and float on all B into first A option. Since later I want to offset level set values with a noise, I need to expand voxels with VDB activate node and calculate closest point. After offsetting values, I deactivating unnecessary voxels, keeping only surface field, finally converting to polygon mesh, caching it, and assigning velocities from velocity volume. Applying reference transformation. Next part is small particles around core. I am taking points what we used for smoke emitter and killing all low speed particles. Next, creating smoke volume emitter. Pyro solver setting almost the same, dissipation is lower here, that's the main difference. Disturbance, turbulence, viscosity staying the same. One thing I forgot to mention, that for both pyro solver nodes I added inside static object node for cell geometry collisions with inverted sign to collide inside geometry. Collision volume itself here, I created VDB from polygons, called field collision and checked fill interior. That's how looks simulation. After caching, again prune low dense areas, filling volume with points and feeding it into PopNet. Similar setting with first PopNet, just here I added PopKill and for cell geometry as well, in case if any particles will leave its boundaries. Advection comes from second pyro simulation. Adjusting p-scale with curve based on normalized age, applying transformation and calculating velocities by ID. Now we can speak about connections between core and cell surface. As an input I take in center spheres and outer cell geometry. Let's set ghosting flag to keep it visible. Center spheres we used as input for smoke emitter, putting them in different groups to be able to split them later, and promoting cell ID from point to primitive back, because I will need to use this attribute for each loop. Inside of for each, I split in geometries, calculating normals for center sphere and scattering few points on its surface. I use spare input to fetch metadata and use iteration detail attribute in expression for seed. Next, creating name ID, projecting point to outer surface with ray node, projection based on normal direction. Creating polylines between points with add node. Then iterating on every polyline, duplicating each 4 times, but you can do how many you want, and slightly shift position for every of it. And recreating name ID. Resample it to add more resolution to polylines. Don't forget check curve view attribute in resample node. Inside attribute VOP, add in some A flow noise to position, controlled by ramp, and in the end smooth it. After for each loop, I apply an animation based on curve view, animating growth forward and backward. Add in polywire to have a shell, and use clean soap to remove degenerative primitives. And finally, referencing transformation. Here is the outer cell part. Doing polyextrude to get shell. Converting to SDF. Perform smooth operation, calculating closest point with VDB analysis, resample volumes, smooth it again and apply small noise. Simple A flow noise. Delayed SDF, another level of noise with absolute values, deactivate voxels, and blast extra fields. I would like to blend between SDFs during time, so I use in blend shapes node and animating mix parameter. Resample VDB and convert into polygons. Smooth in the end. For shading later, I use in one more VDB analysis node, calculating curvature inside and create point attribute from it with attribute from volume node. Applying reference transformation. The last part is overall Atmo, simple box converted into constant fog, only I subtract volume of cells from it. For lights I have dome light with studio HDR, top strong light, and 3/4 weak light. For both inner and outer cell surface, I'm using Fresnel to control opacity of it. Connections has transmission shader. Body has transmission and subsurface shader with opacity set to 0.6. Small particles is subtle layer. Next, outer surface, again opacity here controlled by Fresnel. Body smoke layer needed to absorb some light for the core. Smoke inside cell, just basically some volume with noise. And last thing is general Atmo. That's it. Hope you enjoy it.